Welcome to this lecture on embedded systems. So this is Unit 1, Introduction to the Embedded Systems. So this is the syllabus. The syllabus consists of the first thing consists of the Introduction to the Embedded Systems, structural units in the embedded processors, and selection of the processors and the memory devices. So these are all the very important topics which are going to should be covered in order to understand the concepts of embedded systems. So these three topics will be clearly seeing the introduction to the embedded systems and the ways of selecting the embedded processors and the memory devices for various embedded system applications. The next continue to be the memory management methods, which consist of DMA and the virtual memory concepts. So these concepts are very important when we are going for the operating system concepts. Also the next will be the timer and the counting devices, voice lock timer and real-time clock. So these are all the timer management topics. So all the embedded systems are mainly working under the basis of the timers and the counting devices. So these introductions are going to be very important in case of designing the embedded systems. And the next will be the in-circuit emulators and the target hardware debugging. So these two are very much important when we are dealing with the embedded systems testing. So this is all about the very brief about this Unit 1, Introduction to the Embedded Systems. So we shall go into the first unit. So first going into the embedded systems, we will be seeing what is the meaning of the embedded system. A system is defined as the way of organizing or doing many things according to the given plan or a program. So if a program is being given or a plan is being given, the system will organize itself and do the things whichever it is being planned or programmed. So embedded system is a computer hardware in which the computer software will be embedded, that is installed. So these two together will be working as a system for a dedicated application. So this embedded system will be different from the general purpose computing devices from the application specific point of view. And also the embedded systems will be dealing with the systems where we are having the time constraints. So mainly the general purpose computing devices won't deal with the timing constraints. So the embedded systems will be behaving within sense of the timing sensitivity. So the embedded systems are going to be a multidisciplinary topic which may be dealing with computer science and electronics, electrical, mechanical, and even for the mechatronics too. And also this can be applicable for the applications of chemical engineering, plastic engineering, like this, it goes so on. And also for the military applications and the space applications also the embedded systems will be applicable, and in the day-to-day life we will be dealing with the many embedded systems in practical. So mainly the embedded systems are going to be basically the real-time systems. So real-time means they will be working under the real-time constraints. So based upon these constraints, we will be classifying the real-time systems into two. One is hard real-time systems and another one is soft real-time systems. The hard real-time systems have the stringent deadlines, so they cannot be related at any cost. So the deadline should be finished within the particular given deadline, otherwise the catastrophic will be occurred. So example for this particular type of hard real-time systems are going to be war plane control systems and AT networking tasks. etc. And also for the software real-time system, the deadlines may not be may be flexible, so they may not be stringent at all. So if the system cannot meet with the deadline, it is not a problem. So for an example, we will be having the electronic toys. So whenever the toy is being executed, so the toy may have some real-time constraints. So those real-time constraints may not be, sometimes may not be may not be executed, so that the it won't go for any catastrophic events. So such ways the electronic toy may be given as a software real-time system. So based upon the applications, we can segregate the embedded systems into three parts: small, medium, and the larger are the sophisticated embedded systems. So here some of the examples has been given: the telecom smart cards, missiles and the satellites, computer networking systems and the peripherals, digital consumer electronics and the automotive electronics. So these are all the main examples for the embedded systems. So here you can see the smart card and the telecom will be the smart card will be coming under the small embedded systems, because it deals only with the only one embedded processor, which have its own storage and the networking capabilities. So it won't need any sophisticated systems to be dealt with the smart card systems. So these smart cards can be dealt in the banking and the telephonic security systems. And if you are going for the telecom systems, there may be some media processing may be available, so may be needed. So media processing and the network processing are not going to be in the same only single chip. So those single chips may be designed with the application specific or the VLSI technology. So from that the complication of the ICs will be getting more and more, so that the telecom systems will be coming under the medium size embedded systems. And also the computer networking systems and peripherals also coming under the category of and also the digital consumer electronics will be coming under the category of medium real-time systems. And the missiles, satellites and the automotive systems are coming under the sophisticated embedded systems, because these particular systems may have single purpose processors also, they may have general purpose processors also, they may have the clusters of these processors. So depending upon the availability and the need of the systems, we will be choosing the processors, and the cluster of processors will be working, and the cluster of processors are going to be controlled in a controlled manner, is going to be called the sophisticated embedded systems. So these kind of sophisticated embedded systems are implemented in the missiles, satellites and the automotive electronics too. So when we are coming under the topic of the components of the embedded systems, we will be having these type of components in an embedded system. So mainly the processors and the memory devices will be there. So the memory devices can be segregated into program memory and the data memory. These particular program memory and data memory may not be a single entity. There can be primary memories also and secondary memories also, like hard disk, main processor memory, or the RAM and ROM likewise. So they may be also the parallel ports and the serial ports, input-output interfacing devices. So these are all going to be a main constituting components of an embedded system. And also, in order to given the power supply, and the power supply and the resetting oscillator circuits are being used, because the oscillator circuits should should feed for this particular timer. So depending upon the clock frequency which has been set in this particular oscillator circuits, the timers will be set. And depending upon the timer's output configurations, so these serial communication devices and the parallel communication ports will be activated. So these are all the main components of the embedded systems. So these are all the main hardware components of the embedded systems. So whenever we are going for the software part, we will be having operating systems and the system softwares also. So these softwares are going to be dealing with the users programs. So these user programs will be having these system software and the operating system softwares to communicate with this particular hardware. So these are all the hardware components which is being given here. So this software will be communicating with this hardware, and they will be doing the work which has been given by the user, so within the given time period. So to perform this series of tasks and the threads, we will be having the application software. So this application software may be having the operating systems also. Whenever we are dealing with the operating systems in the embedded systems, they should not be general purpose operating systems. They should be on real-time operating systems, because the general purpose operating systems having all the components of a particular computer software. So they may not be it may not be required for an particular embedded system. So in order to cater the particular need of an embedded system, we will be tailor-made that particular operating system into a real-time operating system. So this particular real-time operating system to supervise the application software to prioritize the usages of the resources, which is according to the schedules. So these are all the main components which we need to look on for an embedded system. It is not merely a hardware part, and also it deals with software parts also. So here we have given some general purpose some differences between the general purpose computing and the embedded systems. So here we will be having the system which may be consisting of generic hardware and the software part. So here we will be having combination of special purpose hardware and the special purpose softwares. So set of applications also being available in an embedded system. Also the general purpose computing having general purpose operating system, and this embedded system may have real-time operating system or may not be having real-time operating system, because whenever we are going for a small embedded system, we may not require RTOS also, RTOS itself, because the particular system software which is being used in those embedded systems may require some of the resources to be utilized within the borders of the particular processor. So they may not be required some RTOS also, because they may not be available with application software. So if you are having application software, means if you want to communicate with the processor, then you need to have an operating system. So if you don't have any application software, you don't need any operating system. So the embedded systems may have operating systems, may not have operating system. Medium and small scale embedded systems may not need this kind of operating systems. Sophisticated embedded systems need RTOS. So most of the things which are going to be application specific in case of the embedded systems. So the performance is a key one in embedded systems, because the performance parameters are going to be the power requirements and the memory usage. So these are all going to be application specific in nature. So whenever we are seeing with the counterpart of general purpose computing, we will be having the faster is the better manner. But in embedded systems, we have some of the performance indices for an embedded systems to be catered under particular systems. Also, the other difference is going to be the general purpose processors are having been tailor-made, and the different levels of power consumption or power management may be required. So, but in case of embedded systems, this kind of power management is highly required, because the highly tailored to take the advantage of this particular power saving models are being required for embedded systems, because these embedded systems are going to be installed in very rugged situations too. So in those situations, the battery drain is inevitable. So that is going to be a big problem for a designer of an embedded system. So he or she need to take care of the power consumption of a system which is being designed. So the response is going to be time critical for an embedded systems, but it is not mandatory for an general purpose computing. So that's all about this particular differences between the general purpose computing and the embedded systems. So next we are going to see about the characteristics and the constraints of embedded systems. So in case of the characteristics, so the real-time and the multi-rate operations are being required in embedded systems, because the embedded systems will be dealing with audio, video, data processing. Also the network streams also can be dealt in an embedded system. So that is going to be a character of an embedded system, because it won't deal with a single signal type of signal. So it may deal with analog signals and the digital signals, or it may be dealing with the multi-rate and the mixed signals. So second characteristics is going to be complex algorithms and the complex graphical user interface, because all the embedded systems may have the complex algorithms to be defined for an control purpose. So for that particular purpose, we will be having a character of complex algorithm in all the embedded systems. Also, we may have graphical user interfaces also. The next will be the dedicated function. So for an application specific operating embedded systems, we just require dedicated functions to be defined for an embedded system. So that is inevitable. The next is going to be constraints. So the hardware and the software cost is going to be a big constraint for an design of embedded systems, because that is going to be a big headache for a designer. Because depending upon the cost and the production cost, the components of the embedded systems may change. Also, the performance is going to be another requirement for an embedded system. So the balance between the cost and the performance is very much needed in case of the design of embedded system. And the next is going to be a real-time constraint. So this is what we have seen in the definition itself. And also the next constraint is going to be power consumption. So as we have said, the embedded systems may be installed in a rugged situation too. So in that situation, the power consumption is going to be a main constraint for the installed system.